The reason we learned example 3 with complex conjugates is that whenever you have a fraction, you cannot leave an I in your denominator. So same rule basically as when you had radicals in your denominator. It's not simplified until you get rid of that. So we need to multiply your quotient, that's 2 plus 3i, and what we're going to do is we're going to multiply that by the conjugate, because we know when you multiply by the conjugate of the 4 plus 2i, anytime you multiply by a conjugate, you're not going to have any i's left in your answer. So if you have a 4 minus 2i on the bottom, you need to multiply top and bottom by a 4 plus 2i. If it was like a 5 plus 7i, then you'd have to multiply both top and bottom by a 5 minus 7i. So if you go ahead and FOIL these, 2 times 4 gives you 8, plus 4i plus 12i plus 6i squared, all over 4 squared minus 2i squared. And then we can simplify this. Once again, you have an I squared here at the end, so we're going to cancel that out and make this a negative 6. So this is going to give us 8 minus 6 is a 2 plus 16i all over 16 minus 4i squared on the bottom. So let's cancel out that I squared. Make this a plus. So you get 2 plus 16i all over 20. And some of you will stop there and I will say, ha ha! That's not right. Because you have a 2, 16, and a 20. And all of them can be divided by 2. So it must be reduced into lowest terms, which will give you a 1, not plus or minus, just plus. 1 plus 8i all over 10. And that is how you write an equation in standard form. Another way you may see it would also be as a 1 over 10 plus, now if you go 8 over 10i, then this one can be reduced to a 4/5 I. So be careful there. You don't want to leave that as a 1 over 10 plus an 8/10 I, because that can be reduced a little bit further.